In this section of 1.3, we're going to find the value of the 6 trig functions given a point on the terminal side. So that looks something like this, where our initial angle is, our initial array is here, and then our terminal side, we're going to use number 37 for our example. So I'll do -5/9, positive 2/3. So our terminal side goes through this point over here. So we're looking at finding the 6 trig functions for this angle. And my point here that they gave me is P -5/9, 2/3. So I'm going to convert that. I'm going to use similar triangles. So instead of, I'm going to use a different point on that same terminal side, but further up, so some multiple of it, so that I can use whole numbers. So I'm going to take both those points, and I want to get rid of the denominator. So a common denominator there is 9. If I multiply both sides by 9, then I will get rid of the denominator on both fractions. So for the x, we'll do that times 9, which gives me the 9's cancel, so my fraction goes away, and I'm left with just -5. And for my y, I have 2/3, and again, I need to multiply by the same thing because I want to use similar triangles, so I need to multiply by the same number for both x and y, so I'm using the same, so it's still proportional. And these fractions will cancel, so I get 1 and 3, and I get 2 times 3 is 6. So I'm going to use some other point up here that's on the same terminal side, but my point is 5, 6. So my x is -5, my y is 6, and then to find r, I use the square root of x squared plus y squared, which is, the 5 squared is 25, the 6 squared, which is 36. And 61 is prime, so I cannot reduce that anymore. So I get r equals square root of 61. R is always positive, so it's a positive square root of 61. And then I can do my 6 trig functions. So here we have our 6 trig functions in terms of x's and y's and r's. And put some color on it so we can kind of plug in all these values. So I'm plugging in all my r's right now. And then I'll do my x's. And then my y's. That looks pretty good. I'm going to take it one step further to simplify it. This one I could rationalize, and cosine I could rationalize. I'm going to put the negative out in front. And tangent looks pretty good. I'm just going to put out the negative out in front. Same with cotan. This one, I'll just bring the negative out in front. And actually, secant looks pretty good as is. Okay, that's my final answer.